Hello students, this class is about definite integral. It is an integral with a definite interval. Like if you integrate fx is equal to x, normally you will get it as x square by 2 plus c. But if I want to integrate this function over a specific interval, let's say from 1 to 2, like the value of x is varying between 1 and 2. So then the integration would be x square by 2, and we have to substitute the limits from 1 to 2. So it's 2 square by 2, 2 square by 2 it's 2, and 1 square by 2 is 1 by 2. So it's basically 3 by 2. So in a definite integral we have a upper limit and a lower limit. It can also be considered as a algebraic area under curve. Algebraic area under curve. Why the word algebraic? Let me explain you. Like if you have a curve like this, so let's say from 0 to some interval a, so x is varying from 0 to a. Now if you find the interval of this integration of this function from 0 to a, what you will get is, let's say the area of this region, say the area of this region is a1, and the area of this region is a2, and the area of this region is a3. So what you will get is a1 minus a2 plus a3. Why a minus sign here? Because this area is under the x-axis, is lying below the x-axis. So to find the algebraic sum of the area, we subtract the area which is below the x-axis and add the areas which is above the x-axis. So if I need to find the area under curve normally, then I would say it's a1 plus a2 plus a3. And always the area is positive, so all these are positive. a1, a2, a3 all should be greater than 0. But for the algebraic sum, a2 is positive, but we'll put a negative sign here to denote that the area is below the x-axis. Another way to represent a definite integral is, like suppose you have a integration of a function fx from a to b dx. It can be represented in the form of an series, infinite series with limit n tending to infinity. Summation r equal to 0 to n minus 1 f of a plus r h, where h is equal to b minus a by n. So a definite integral can be expressed in the form of this series, or conversely this series can be expressed in the form of a definite integral. Let me tell you how do we convert this series into form of a definite integral. First of all, we have to express the series in the form like this: summation of 1 by n f of r by n. So f of a plus rh has to be converted to r by n, f of r by n, and 1 by n. Then we take r by n as x, so we get dr by dn as dx. Dr by n is a constant, so dr by n is dx. So my integration, this would be integration of, we have to put the limiting values of r, so it would be some a to b fx dx. So this by n will be replaced by this dr by n would be replaced by dx. Let's see an example to understand this. Suppose we have a function like this and we have to evaluate its value. So how can we evaluate its limit? First let's try to convert it into a definite integral. So like this we can write as n plus 1, n plus 2, n plus 2n. 3n can be written as n plus 2n. Now if let's say this is equal to y, let's say this term is equal to y, and now let's take log on both the sides. So we have 1 by n log of n plus 1, n plus 2, n plus 2n by n raised to the power 2n is equal to log y. Let this is equal to y. Now we can write it as 1 by n log of n plus 1 by n plus log of n plus 2 by n. Since these are in multiplication, so we know that log of ab is always equal to log a plus log b. So by using that property we can write it in the form of a summation, log of n plus 3 by n log of n plus 2n by n. So is equal to log y. So this can be written as 1 by n summation log of n plus r by n, where r is varying from 1 to 2n, right? So this can also be written as 1 plus r by n. Now since we have written it to be like this, 1 by n summation r equal to 1 to 2n log of 1 plus r by n, this can be written as integration of log of 1 plus x dx. This is limit n tending to infinity. So it can be written as this, and the limit would vary from, so if we take r by n equal to x, and r is varying from 1 to 2n, so if I take r equal to 1, then x is equal to 1 by n, and if I take r is equal to 2n, then x is equal to 2. It's 1 to 2. So if we take 1 plus x equal to t, so it's dx equal to dt, so it's log t dt from 2 to 3. Now you can solve this integration, and the value will be equal to log of y, what we have got here. Now let's see some of the properties of definite integrals. So the first property is that the change of variable is immaterial. Like if you have function from fx dx from a to b, then you can write it as a to b ft dt. So changing x to t does not make any difference. The second property is if you have integration a to b fx dx, then you can write it as minus b to a f of x dx. So if you exchange the upper and the lower limits, a minus sign comes. Then the third property is if you have a to b fx dx and c is any number lying between a and b, then you can split this integral into two. First from a to c, which is a to c fx dx, plus then c to b fx dx. The fourth property is a to b of fx dx is always equal to a to b f of a plus b minus x dx. So if you add the upper and the lower limit and subtract x from it, so then the integrals are always equal. The fifth property is if f of x equal to f of a minus x, then if your integral is from 0 to a f of x dx, you can write it as twice of 0 to a by 2 f of x dx. So this thing is possible if you have f of x equal to f of a minus x. Normally you cannot apply this. First you have to check that f of x is equal to f of a minus x. Then the sixth property is minus a to a. If the limit is from negative a to positive a, f of x dx is equal to 0 to a of fx plus f of minus x dx. And now here if your f of minus x is equal to minus of f of x, that's in the case of a odd function, then your integral becomes 0. But if you have a even function, that is f of minus x equal to f of x, there is no negative sign outside, then this integral becomes 0 to a twice of fx dx. So these were the some basic properties related to definite integrals. Now we'll see some previous year JEE Mains questions based on these properties. The first question is evaluate the integral 8 cos 2x divided by tan x plus cot x whole cube from pi by 12 to pi by 4. So how do we proceed in such situations when we have tan x plus cot x? We simply convert them into sin x and cos x. Like tan x can be written as sin x by cos x and cot x can be written as cos x by sin x. So if I add them, I'll get cos x sin x and sin square x plus cos square x. So if you have tan x plus cot x, you write it as sin x by cos x plus cos x by sin x, and it becomes sin square x plus cos square x. It is 1 by cos x sin x. So in case of tan x plus cot x, we can replace it by 1 by cos x sin x. Now if we substitute it here, we'll get 8 cos 2x 1 by cos x sin x whole cube. If I multiply and divide it by 2, I'll get 8 cos 2x 8 upon 2 cos x sin x is sin 2x whole cube. Now if we simplify it, we get cos x 2x sin cube 2x by 8. So now if we take 2x equal to t and dx equal to dt by 2, so our integral would be, so my integral becomes x has been replaced by t. So 2x has been replaced by t. So if my x is pi by 4, then t would be pi by 2, and when my x is pi by 12, so t would be pi by 6. So it would be cos t. So my function would be cos t and sin cube t dt by 2. So like if I take sin t to be z here, I get cos t dt equal to dz, and my dt would be dz by cos t. So if I change it here, now t is from pi by 6, sin pi by 6 is 1 by 2 and sin pi by 2 is 1. So it's 1 by 2 to 1 cos t z cube by 2 into dt is dz by cos t, and cos t would get cancelled and my integration would be z raised to the power 4 by 2 and the limits 1 by 2 to 1. You can solve this yourself. So my another question is, the integration is from 1 to 2 dx x square minus 2x plus 4 raised to the power 3 by 2. So in such kind of questions, since we know that the power is 3 by 2, we try to complete the square for this, like x square minus 2x plus 4, x square minus 2x plus 4, I can write it as x square minus 2x plus 1 plus 3. Now this is x minus 1 whole square plus under root 3 whole square. So if I write it like this, this would be equal to 1 to 2 dx x minus 1 whole square plus under root 3 whole square power 3 by 2. Now if we have 1 upon under root of, if we have questions like this, 1 upon under root 1 upon 1 divided by x square plus a square raised to power 3 by 2 or 5 by 2, something like that, we take x equal to a tan theta. So now here a is root 3, so we'll take, and x is x minus 1, so we'll take x minus 1 is equal to root 3 tan theta. So dx is root 3 sec square theta d theta. Right, so if I replace it here, we get, the limits would also change, since x is equal to 1, so this is 0, so tan theta is also equal to 0, and if we put x equal to 2, you get tan theta equal to 1 by root 3, and this is equal to theta, this implies theta is equal to pi by 6. So your limits of integration is from 0 to pi by 6. Dx is under root 3 sec square theta d theta divided by x minus 1 is root 3 tan theta. So squaring it, we get 3 tan square theta plus 3 to the power 3 by 2. Now we can write it as taking 3 common, 1 plus tan square theta, which is nothing but sec square theta. So this will become under root of 3 sec square theta d theta 3 sec square theta raised to the power 3 by 2. So after solving this, we get root 3 sec square theta d theta 3 raised to the power 3 by 2 and sec cube theta. Now, so after cancelling this, we are left with d theta by 3 sec theta, and the limit of integration is from 0 to pi by 6. 0 to pi by 6 d theta by 3 sec theta, we can write it as 1 by 3 cos theta d theta. The integration of cos theta is sin theta. The limit from 0 to pi by 6. Sin pi by 6 is sin 30, which is 1 by 2. And sin 0 is 0 multiplied by 1 by 3. So we get the answer to be 1 by 6. So first we converted this into a quadratic equation with a whole square, and then we substituted x equal to a tan theta, and then we evaluated the integral, we got it to be 1 by 6. So this k by k plus 5 is equal to 1 by 6. So k is equal to 1. Now we have another question. It seems difficult at the first moment, but you make sure you remember the property when you see e raised to the power x. It's integration of ex fx plus f dash x dx from a to b is always equal to ex fx. So if we can convert this part of the question into the form fx plus f dash x, then we can directly evaluate this integral. So let's see how can we do this. First we'll write it as ex 1 plus 1 minus x square 1 minus x raised to power 3 by 2 1 plus x raised to power 1 by 2. Now it can be written as e to the power x multiplied by this 1 minus x 3 by 2 1 plus x 1 raised to power 1 by 2 plus e raised to the power x 1 minus x square 1 minus x raised to the power 3 by 2 and 1 plus x raised to the power 1 by 2. Right. So now this 1 minus x square can be written as 1 minus x and 1 plus x. So if we evaluate this, we can write it as e raised to the power x 1 minus x 1 plus x. It will be 1 minus x 3 by 2 1 plus x raised to the power 1 by 2. So if we cancel it, this will become 1 by 2. Cancel it, this will become 1 by 2. So we are left with e raised to the power x under root of 1 plus x divided by 1 minus x. So now if you find the difference, if you take fx to be under root of 1 plus x divided by 1 minus x and find its differentiation, you find, so it would be 1 minus x integration of the numerator, which is 1 by 2 under root of 1 plus x multiplied by under root of 1 minus x minus 1 by 2 under root of 1 minus x under root of 1 plus x. This sign would become positive because we have a minus x, so it would be 2 under root of 1 plus x under root of 1 minus x, and here we have 1 minus x plus 1 plus x divided by 1 minus x. So it would be 1 plus x raised to the power 1 by 2 and 1 minus x raised to the power 3 by 2. So this is what is equal to this. This we have got it as equal to this. So we have ex fx plus f dash x. So the integration of this would be, so the integration would be equal to 0 say 1 by, the answer would be e raised to the power x under root of 1 plus x minus x, limits from 0 to 1 by 2. If you substitute it, you will get e raised to the power 1 by 2 under root of 1 plus 1 by 2 1 minus 1 by 2 minus e raised to the power 0 is 1 and this is 1. So this will be your answer. You can simplify it more. So if you have been given twice of 0 to 1 integration of tan inverse x dx is equal to limits from 0 to 1 cot inverse of 1 minus x plus x square dx, then you have to find the value of this. So let's see, cot inverse x can always be written as pi by 2 minus tan inverse x, right? So we can write it as 0 to 1 cot inverse of 1 minus x plus x square can be written as pi by 2 integration from 0 to 1 pi by 2 minus tan inverse 1 minus x plus x square dx. So I got 2 tan inverse x 0 to 1 dx is equal to pi by 2 minus 0 to 1 tan inverse 1 minus x plus x square dx. Now if I rearrange the terms, I get 0 to 1 tan inverse 1 minus x plus x square to be equal to pi by 2 minus 0 to 1 twice of tan inverse x dx. Right. So now to find the value of this expression, we just have to evaluate this. So now if you substitute x to be tan theta, dx would be sec square theta d theta. So let's say this integral is equal to I. So our I would be equal to pi by 2 minus twice of, the limits would change since x is from 0 to 1, so the limits of theta would be 0 to pi by 4. So tan inverse of tan theta is theta, and then sec square theta d theta. So let's take, we can use isolate here since we have to use the by parts. So it would be, let's first evaluate only this integral. So by evaluating this integral we can get theta, integration of sec square theta is tan theta minus differentiation of first integration of tan theta, so which is equal to theta into tan theta minus log mod sec theta. The integration is from 0 to pi by 4. So if we write pi by 4, tan pi by 4 is 1 and sec pi by 4 is root 2. So log root 2 minus, if we substitute 0, this term is 0 and this term would be log 1, which is also 0. So my answer is this. So if I write it here, we get it as pi by 2 minus twice of pi by 4 minus log of under root 2. So this is pi by 2 minus pi by 2 plus twice of log under root 2, and this would get cancelled and we will get log 2. So we have finally found the value of this integral, which we have taken it to be I. So our I is equal to log 2. Now let's consider this integral. We are taking up the questions based on each and every property of the definite integral so that you can revise all of them at once. So it is 1. Now 4 sine square x by 2 can be written as 2 sine x by 2 whole square, and then minus 2 multiplied by 2 sine x by 2. This can be, so your 4 sine square x by 2 is 2 sine x by 2 whole square, and 4 sine x by 2 can be written as twice of 2 sine x by 2. So this is 1 minus 2 sine x by 2 whole square. So right, so this under root of this can be written as 1 minus 2 sine x by 2 whole square. And now since we know that under root of x square always gives us mod x, so we have to check whether in the interval 0 to 2 pi this is positive or negative. So since in 0 to 2 pi, since in the interval 0 to pi, rho theta less than pi, sine theta is always positive. So in the interval 0 to pi by 2, sine x by 2 would be positive, would be less than 1. So it is always greater than 0. It is 1 minus 2 sine x by 2 dx, integration from 0 to pi. So now you can directly integrate it. Integration of 1 is x and of sine x is plus 2 cos x by 2 divided by 1 by 2, integration from 0 to pi. So we get it as x plus 4 cos x by 2 from 0 to pi. If we substitute pi, this is pi plus 4 cos pi by 2 is 0, so this is 0, and if we substitute 0, this is 0 and cos of 0 is 1, so this is minus 4 So answer is pi minus 4. In this question, we have given sine square x plus 1 raised to the power 1 plus 2 raised to the power x. Let's say this is fx. Let's calculate f of minus x. It would be sine square x 1 plus 2 raised to the power minus x, right? And we know that f of integral of f of x from a to b is always equal to integral of f of b plus a minus x dx to b. So here our a is minus pi by 2 and b is pi by 2. So f of pi by 2 minus pi by 2 minus x is equal to f of minus x. So basically integral of a to b fx is equal to integral of a to b f of minus x dx in this case. In this case specifically. Okay. So let's say this is equal to I, so we can write it as 2I is equal to minus pi by 2 to pi by 2 sine square x divided by 1 plus 2 raised to the power x plus minus pi by 2 to pi by 2 sine square x 1 plus 2 raised to the power minus x. So this quantity is related to integration of f of minus x and this is related to integration of f of x. So that's why we have written it to be equal to 2i. Now let's solve it. We have 2i. From here we have 2i is equal to integration from minus pi by 2 to pi by 2 sine square x plus 2 raised to the power x plus sine square x 1 plus 1 by 2 raised to the power x. So if we simplify it, we get sine square x 2 raised to the power x plus 1 multiplied by 2 raised to the power x. Now the denominators are same in both, so we can write 2i is equal to minus pi by 2 to pi by 2 sine square x common. Here the numerator is sine square x multiplied by 1. It is sine square x multiplied by 2 raised to the power x. So we can write it plus 2 raised to the power x divided by 1 plus 2 raised to the power x dx. Now this and this will get cancelled and we are left with 2i is equal to minus pi by 2 to pi by 2 sine square x dx. Now to simplify this sine square x, we can write it as sine x to be t. So we are left with cos x minus cos x dx equal to dt. So it would be 2 square t by under root of and since t is sine square x plus cos square x is equal to 1. By using this identity you can write cos x in terms of t and this integration would be simplified. So you can simplify it. I'll move on to the next important question. This is the last question and it is very important because it is related to the greatest integer function, which we in short we call it GIF. So let's recall what it is. So if you have any number like 0.5, so the greatest integer of 0.5 should be 0. It gives the greatest integer less than or equal to this number. So greatest integer of x is the greatest integer which is less than x. Like greatest integer of 2.2 is 2. Right. So for evaluating this integral, we should know the at different places from 0 to 1.5 this function will take different values. Like let's say if x lies between 0 to 1, then the greatest integer function of x would be 0. Like for 0.7, 0.8, for every value it's 0. But if our x lies from 1 to 2, the greatest integer function would give us 1. So this function will take different values in the interval 0 to 1.5. So let's see where the greatest integer function x square takes the integer values. It changes its values at the integers, right? So we have to see where this takes the integer values. So if x square is equal to 1, we get x to be under root of 1, which is 1. So if x is from 0 to 1, our x square is also from 0 to 1. So we'll get the greatest integer of x square to be 0. And if x square is 2, then x is equal to under root 2. So if x is from 0 to under root 2, then 1 to under root 2, then x square would be from 1 to 2, and we get the x square, greatest integer of x square as 1. Now if we take x square equal to 3, x would be equal to under root 3. But under root 3 is equal to 1.7. So we need not consider this because this is greater than 1.5. So we'll take values till 1.5 only. So we can write it as 0 to 1 plus 1 to under root 2 plus under root 2 to 1.5. Now in 0 to 1, our greatest integer of x square is 0. So this will become 0, and in the end it will become 0. When it is from 1 to root 2, when this x is from 1 to root 2, our greatest integer is 1. So this value is 1, so we are left with only x dx. And from root 2 to 1.5, root 2 is 1.4, and till 1.5, so the answer would also be 1. Greatest integer of x square would be 1. So it would be 1, same x dx. So our x square is from here to here. So our x is basically from root 2 to 1.5. It will give us 1. Yeah. So we have x square by 2, 1 to root 2 plus same. We can directly write 1 to 1.5, which is equal to 1.5 square by 2. You can evaluate this. That would be the answer for this. So students, that's all for today's class.